This is Intermediate Algebra. I'm at 1033, Chapter 2, Section 5, Compound Inequalities. Don't let the word compound mess you up. Think that it's any more difficult than anything else. All it is really two inequalities, and you graph either the intersection or the union. Make sure you remember that "and" means intersection, "or" means union. So for instance, if we look at example 2, we have x minus 7 less than 2 and 2x plus 1 less than 9. So what we're going to have to do is we're going to have to graph both of these, and where the intersection comes with both of these, that's our answer. So the first thing I do is add the 7 to the other side. I get x less than 9. This one here, I subtract the 1, and I divide by the 2, and I get x less than 4. So in red, it's parentheses, less than 4. Here it's parentheses for the 9 in black, and less than. So we can clearly see that the intersection between the two is where the red and the black come together. That happens to be x is less than 4, and we indicate that. So here's our graphical notation, here's our algebraic. Our interval notation is we're coming from negative infinity, which is parentheses. We're stopping at parentheses 4. Here's another way this can be written. If you ever get a compounding quantity written in this manner, it is "and," it's an intersection, and you can actually solve both sides at the same time. So the first step I did here was I want to get rid of the fraction, so I'm going to multiply the whole thing by 3. So 3 times negative 1 is negative 3. 3 times the 2x over 3 is 2x. 3 times the 5 is 15. 3 times the 2 is 10. Now I'm in two-step form, and I can solve it. I'm going to subtract 15 from both sides, so I get the negative 18 and negative 5. Then I'm going to divide by 2, and I get negative 9, negative 5 halves. Whenever you're solving a compound inequality in this form, it gives you the answer already in intersection form. So what I'm doing is I'm writing the negative 9 with a bracket. So I'm writing negative 9 coming from the left side, the smaller part. I'm hitting bracket negative 9, going to bracket 5 halves, or negative 5 halves. Notice I got my 0 here, so I know both of them are on the left side. And all I got to do is copy this. It's bracket negative 9, comma, bracket negative 5 halves. Coming over here with example 7, or, we have 5x minus 3 less than or equal to 10, or x plus 1 greater than or equal to 5. In terms of this one, add the 3 over, divide by 5, we get x is less than or equal to 13/5. Here, subtract the 1, we get x is greater than or equal to 4. Or means we want the union. Or means we're taking everything that's possible, but don't repeat anything. So if I graph the x less than or equal to 13/5, it's a bracket, everything going to the left. Graph the x greater than or equal to 4, it's a bracket, everything to the right. So both of these are my solution because it's an or. Had it been an and, there would be no solution because there's no intersection. So when I write this in interval notation, incidentally, this is algebraic notation already, don't have to mess with it. There's graphical. Interval, I'm coming from the left, I'm coming from negative infinity, I'm stopping at bracket 13/5, or I'm starting at bracket 4 and going to positive infinity. That's all there is to compound inequalities.